Hello, everyone. Thank you for joining us today during our webinar. The topic at hand, we're going to be discussing unleashing the potential of IIoT for predictive maintenance and empowering maintenance excellence. I'm Chris Schneck. I'm our business development manager here at Grace Technologies. I've been with the team now for about 5 years. The team has grown significantly within the last year or so. I manage a team of about 3 different business development coordinators. Our job is to really have customer-facing interactions, discussions regarding electrical safety, equipment health monitoring, and helping bridge the gap between customers' current state and get them into their future state requirements. I also am joined today with Bryce Brewer.
Yep. So I'm Bryce Brewer. I'm an IoT product engineer here at Grace. Been here for about 6 years, and I'm now working mainly with customers to develop solutions within our predictive maintenance product line and trying to, work with their applications and our engineering team to come up with, a very beneficial and a cohesive solution for them. So today we're going to be covering, a kind of a brief history of predictive maintenance. So from the beginning to where we are now. We're going to go over the benefits of IoT. We're going to talk about, how do we monitor assets? And then now that we have them monitored, what do we do to make a decision on how we perform a maintenance activity? Yep. And then from there, moving on to some of the things we're seeing in data analytics. And lastly, kind of our ROI and safety talk. So, if we're putting an investment into a type of monitoring equipment, how do we get, a return on investment on that? Because it's sometimes not as cut and dry as, you get a piece of equipment that is going to make so many widgets per day. Well, you can do a calculation pretty easy on how much how long it's going to take to pay you back there. So with that, we'll kind of jump into some of the history side of things. So, when did predictive maintenance start becoming a thing, Chris?
Yeah, well, domestically here, it really started taking off back in the early 60s, 1960s. There was early fault detection and kind of insight into equipment health monitoring. And then from there, it's just kind of naturally progressed into what it is today. But origins date back to the early 1960s. Yeah,
and that was with vibration monitoring is really the key, is the first step there. So, that's a lot of the interest still today is on how do we get information on our motors, pumps, fans in our facility? Because that's obviously a big part of production, is keeping those assets running. And the 1960s is when we're talking predictive maintenance. That doesn't mean that maintenance wasn't being done before then, or there wasn't condition-based monitoring or things like that. But this is like, how do we gather data? We have some analytics on it, and now we're trying to predict how long do we have to run this equipment? When do we need to perform the maintenance activity? So that's kind of the origins of that.
And so I assume there's probably been further advancements from the 1960s to current in between that time. So from probably the early 90s on, I know that there was a big push, like you mentioned, aggregating that data, collecting that data on that asset. But ultimately, what did they do? How did they access that data? What were some of the advancements that we saw from the 60s to now?
Yeah. So the big thing there was consolidating of data into one kind of key location. So instead of having a disparate source of data on each machine, now we need to look at a plant-wide level and look down at the entire operation. So that was really done with CMMS systems, or a computerized maintenance management system. So that allowed you to gather data and send out work orders and just have a cohesive kind of tool that we can use the technology to help drive and organize the work we're doing. So, that's the big thing, is as we've seen improvements on computational capacity, we've seen, innovators in the industry taking that and saying, okay, that had, other uses maybe for the different sectors. How do we use that within our facilities?
Sure. And then even now, kind of post 2000s, more recently, within the last year or so, ChatGPT, AI, that's obviously an advancement that we're currently dealing with. But obviously from the 90s on, there's definitely been improvements within AI integration and having that kind of advanced analytics from a just an AI perspective as well.
Yeah, and I do think that that's going to be where we're going to see a lot of innovation in the next few years. I was very surprised with the level of detail and accuracy that came out of ChatGPT and related technologies. I always thought AI was still in its learning phases, but man, when that was released, it just kind of turned everything on its head. And so I think we're going to see that really deployed in a lot of industrial technologies in the predictive maintenance space, but really in every sector.
Absolutely. Instead of being a college kid trying to write a paper and using ChatGPT, I certainly envision this being an integral part of any IoT or predictive maintenance offering as well.
Yeah. And I mean, with that, there's so many more sensors out there gathering more and more data. So there's just going to be larger and larger data sets that allows us to provide a lot better information on not just a lab setting, which is, a lot of what is done in the beginning is, we test it in a lab and we try to induce failure modes and that. But once it gets out on real equipment, gathering that data is super hard to get, but we're just starting to get more and more deployments, more and more data coming in. So I think that that's going to really aid in some of the predictive side of things. So taking that data and making a prediction on how long it's going to last, what we need to do.
Yep, absolutely. So we are going to be reading some statistics just throughout the webinar. One key statistic that we want to touch on here, obviously bridging the gap and kind of rounding this all out from past to current. So a key statistic here, maintenance strategies have seen a 24% increase in utilizing CMMS or computerized maintenance management systems since 2019. So again, that's so recent. That's only 3-4 years ago.
Yeah.
Referencing that, and then even into the advancements of AI into the future. Today, 52% of maintenance strategies in the manufacturing industry utilize CMMS, and 41% use predictive maintenance with analytical tools.
Yeah, it's definitely becoming a bigger and bigger part. And one last thing that I'm seeing is potential for the next few years is we're just seeing so much in the EV world on battery technology. So like batteries, I think that's a huge part of an IoT system, a wireless system, being able to last longer, use less power. Just, every few years there's a new generation of microchips that use a little less power, have a little more computational power. So that's just something that is going to keep growing to where we're going to start to see where they're really going to be easy to deploy, long battery life is just going to keep improving that. We're already seeing it today, but I think it's going to just continue to improve.
Yeah, harvesting that energy that already exists in a plant floor environment, right? So making sure that, like you said, battery lasts longer, it's able to collect more data, have a higher sampling rate. Really, I think the EV and renewable energy is going to be a big part of that as well from a predictive maintenance offering.
Yeah, I think the energy harvesting, there's so many different sources of energy within a plant, and we're seeing some cool technologies coming out on, using the motor's flux or temperature or something like that in order to vibration even to get some level of power. And some of them are kind of still in an infantile stage. We're still in a alpha beta stage of getting that out there, but I think that we're going to really start to hone in on being able to harness the power and make it to where you don't have to have batteries. We're thinking, oil fields and things like that, where it might not be manned, but you want to get a pressure or a flow or something like that from your equipment. So being able to do that and not have to change a battery is huge. So with that, we're going to jump into kind of, now that we talked about the history, how does predictive maintenance work at a high level? So it doesn't just start where we're giving out answers, right? We're telling you how you should go about your maintenance activities. So kind of where does that start, Chris?
Yeah, I mean, first and foremost, it's going to be data collection, right? We got to understand and baseline and trend out your equipment health, really understand its operational capacities, and then really start to kind of hone in and identify if things are starting to fall out of normalcy or display anomalous behavior. That's where that kind of data collection piece will come into play, absolutely, from a initial jumping off perspective.
Yeah, so you have to collect the data, and there's a variety of sensors and signal types. Generally, they're all electrical and 4 to 20, 0 to 10 volts, resistance, that type of thing, where, okay, now we're taking the physical and we're getting it into a signal that we can use. So now we get that signal and now we have a data point. Well, what do we do with this? We have to congregate it and then provide analytics on top of that. So the analytics can be really focused on the application, or they can be more generic. Sure. So that's the first step. Collect the data, do some initial analytics, and then from there, the predictive part comes in. So that's when you're taking advanced algorithms from the analysis you've done and saying, okay, based on our experience, we're seeing this trend. What does that mean as far as, can I make it to my next shutdown in 9 months? Or do I need to, shut down before then? And so that's where
intervene quicker.
Yeah. So that's kind of the biggest thing, is trying to plan these activities, because ultimately you're not going to put on a monitoring type device and it's going to remove your need to perform maintenance. It's just, ideally we can learn about the equipment and do it on our terms versus when the machine decides it's done working.
Yeah. So that kind of ties in nicely, right? So data collection, data analytics, predictive maintenance, and then tying it all back into the maintenance spectrum that is currently being deployed at your specific facility. Having schedule-based maintenance, ensuring that folks are intervening as they need, right? Not just relying on, we have a shutdown in 9 months, that's when we're going to perform maintenance. If something is occurring and you need to intervene sooner, the predictive analytics piece will allow you to identify that and intervene at a more appropriate time.
And ideally, you can take a cost risk analysis on that. So maybe it's showing signs that, hey, it's probably it might last 9 months, but it's looking more like 6. Then you can make a justification on, do we think it, based on my own experience with this piece of equipment, will it make it, or should I be cautious and take it down before then? So, and the other part of that is kind of changing from a schedule-based approach to a predictive or a condition-based approach. You can reduce some of your maintenance activities if they're being done more frequently than needed. Manufacturer says every 6 months you need to lubricate the bearing. Maybe based on monitoring, we can get a year, and you can cut out one of those
prolong,
tasks.
Prolong it, sure.
Yeah. And then obviously the flip side, what we were talking about of, we're supposed to get this long, but for some reason it's not going to make it that long. What we need to act sooner. So it just gives you some insight to that.
So quick question for you. I know that you have more experience in the field. So even before that data collection, would you say that customers are performing a criticality analysis to identify, hey, this motor is key in my production. If it goes down, there is no redundancy, right? So I guess what is your experience with that when you're on site? Do customers, they probably have an idea of what equipment's most critical, right?
Yeah. So that's a good point. So we kind of jumped ahead of how do I know what I want to monitor?
Yeah, right. That's
so the what is kind of a criticality assessment is a good thing. So we look at how important is every piece of equipment within the facility. If it goes down, do we have a redundant backup? Does it shut down a whole line? There's a lot of things that go into that. But generally speaking, when we're talking getting started, and that's what this is really focused on, is, okay, how do we get started in predictive maintenance? When we're talking about getting started, it's usually looking at what do I think about when I'm off the shift? When I'm at home, am I worrying that I'm going to go in on a Sunday, evening to go and fix this piece of equipment? If that's probably the one you want to monitor, right? So I mean that's a starting point, but ultimately, if you're trying to do a larger scale deployment throughout your facility, that's where the criticality assessment comes into play. Yep. So then, what are some of the challenges? So obviously nothing comes without some level of trade-off. So what are the challenges when we start looking at doing a predictive maintenance approach within a facility? Yeah,
I think the biggest and foremost, obviously, is that identifying which equipment needs to be monitored, what is the most critical, and then from there, having a CapEx expenditure or an OpEx expenditure to ensure that funding is available.
Yeah,
I 100% in my conversations with customers, and I like to mention this. It can be something as little as a small scale deployment or a full plant deployment. We offer something called starter kits. This allows for kind of a low cost investment to physically get your hands on some hardware at a very reduced cost.
Yeah.
So to do some initial testing and, obviously make sure that it's a proper and right fit. And obviously to sell it internally.
Yeah.
You don't have to spend $100,000 to buy a deployment and then, come to find out a year later that it's really not a good fit.
Yeah, that's huge. I mean, being able to have a small scale. I mean, I think that's key. Is let's start on a couple pieces of equipment, see how it goes, take our learnings and apply it before we just dive head first. Which is sometimes that's an appropriate approach, especially there is some fiscal ramifications.
Sure.
We have year-end budget
Excess
or something
budget,
like that where we need to use the money. So
use it or lose it is what I like to call it.
Yeah, that's a little bit different, but generally speaking, just like anything, you like to test drive your car type thing. You probably want to do that with a predictive maintenance system.
I also, one key thing that kind of is reoccurring as well, just the general knowledge of IoT and predictive maintenance. It might be something that puts you out of your comfort zone.
Yeah.
I've talked with a lot of folks that they just know how the equipment is performing because they've worked for the same company for years and years, and they've just gotten very in tune with the equipment itself. And so the way that they troubleshoot currently, they may be walking around on site, they hear a hum or a buzz. And so the thought or the idea of taking that out of the equation and having a solution that could assist with that and in terms of that troubleshooting, it's new. It might cause some discomfort. So I think that is also another challenge that I've faced when having conversations with customers.
Yeah. I think a lot of our customer base is really great with controls, automation, obviously maintenance as a whole. The IoT world is a little different. It's taking, there's oftentimes wireless involved and, we use sensors within the controls world that these are, wireless kind of, they deploy by themselves. There's just a few different things, just how the data gets to, like if it's a cloud-based system, how does, what does the cloud mean? Those type of things.
It's a scary thing, right? Like where's my data going?
Yeah. So that, just how does that all work? So yeah, there is definitely there's some learning steps there. And so, getting the skills to the people who are going to be responsible for it is really important. And it's not something that just you can do necessarily overnight. So usually it's, a good partnership with whoever you're going into business with and deciding to use their technology within your facility.
On top of that, obviously ensuring that the IoT system that is deployed is reliable, that you're getting accurate data collection and true insight into how the equipment is performing. Obviously we want to ensure that once a deployment has occurred, that you're able to not only collect that data, but tying back into the data analytics, the predictive maintenance, and then tying it all back into the maintenance scheduling as well. So reliability, I think, is a concern or a challenge that comes up often as well.
Yeah, and like you said, getting data where you want it, right? Because a lot of the systems, there's the cloud-based deployment or something like that, where the data might not be where you'd like to see it. You'd like to have it in your CMMS or on your SCADA system, so making sure that you can get the data where you want it to where you can utilize it and not have just, a whole bunch of disparate systems where you have to go here to get this type of data, go here to get something else.
Centralized, easily accessible, and documented.
Yeah.
Get it out of here and into a centralized location.
Yep. Yeah. So, but with that, you're going to, there's obviously some challenges, but then the idea is that there's some benefit after we get through that. So what's the outcome of doing one of these deployments?
I would say that the biggest and key outcome that we look for, obviously, is to try to prevent or reduce unplanned downtime. We don't want folks to have to rush and cut corners to get their equipment back up and running. Their boss is yelling at them, "Hey, our production line is down. We're not making money. Let's go." Yeah. So obviously, from a high level perspective, if we're able to identify and capture that and help the folks that are actually performing the maintenance schedule that out, as you mentioned, Whether it be a 6-month cadence and the IoT system saying, listen, you're not going to make it.
Yeah.
You got to intervene now. You have to start your troubleshooting and start the work.
Yeah.
Obviously unplanned downtime reduction is, I would say, the biggest outcome that we look for.
Yeah. That's definitely, the low hanging fruit there. That's the first reason, the primary reason we're doing this. Some other things is just a more efficient spend of your maintenance budget. So, like we said, if you can get away with, not doing so much scheduled work where, it's not just, the lubricant or whatever you're using in that, or is not generally a high cost. It's the person. Yep. And right now, people are hard to find, especially skilled people. We've seen that everywhere we've been. So, getting to where they're only going out and performing activities that need to be done is really important, and that can, stretch your budget because you're not sending people to do tasks that maybe aren't needed right now.
Yep.
So that's part of it, and then also, if it is a piece of equipment that's hard to get parts for, it's in Germany and it's going to cost you, multiple $1,000s to get it expedited to where it's here in a short order. And a short order is generally a couple days, few days at the high end or at the low end, I guess. That can be really impactful when we're talking a system that, a line that costs, say, $260,000, I think is about the average.
Yeah.
So if they had a shutdown on that, that's a lot per hour to be losing.
Yeah, to add to that as well, thinking about expediting and getting parts from international entities, right? Mm-hmm. So we talk about that initial investment, and really that can be quickly returned when you think about the cost of air freighting parts or having to expedite components. Mm-hmm. Certainly that can really add up to a lot of dollars. Like you mentioned, I think you said 260,000 on average.
Yeah.
But on top of that, with a optimized maintenance planning schedule, we're looking at trying to further the life of the equipment. Yeah. We want the equipment to operate more efficiently, last longer than its intended use, right? And just be optimized in how it's performing.
Yeah, and that's a big part of it. And so another statistic here is that, for any piece of equipment that's monitored, there's about a 70 to 75% reduction in unplanned equipment breakdowns when you're using a predictive maintenance system. So, that's a very large reduction, 70 to 75%. So definitely can see the results there on anything that, like I said, keeps you up at night. So
I'm just trying to think, man, coming in on the weekend, Saturday, Sunday, after working all week,
we're blessed.
I would be thinking about that all weekend. And if it happened to fall or, go down heading into the facility, that just sounds not fun.
Yeah, we are on lucky ones compared to some of our customers. But hopefully, when you start looking at these approaches, we can start to reduce some of that. So now if we move on more to the application side, so when we're talking about what applications do we want to monitor, we talked about choosing the type of equipment based on either criticality assessment or just, hey, I know I want to monitor this.
Yes.
The thing is, okay, how do I monitor? What do I monitor? So we mentioned vibration, that's kind of high level. So that's, on anything with a motor. So, anything facility side is great. We've seen a lot in HVAC, compressors, chillers, that type of thing, pumps, fans, those are
material
really
handling, conveyor systems, I assume as well.
Yep. We, for vibration monitoring, it's really, especially continuous equipment, that's just an easy first step into vibration monitoring. Another easy one is temperature. So temperature is a really basic, but it can be really powerful. So that can be for refrigeration, if you need to keep product within a certain range, that's obviously a very important part of it. And I believe you said that you had a customer that
they manufacture ice cream.
Yep.
And during the production process, right, they need to keep their product at a certain temperature. Now, when you think of temperature monitoring, usually it's on the high end, like hot spots, right? Mm-hmm. In this situation, they wanted to ensure that their freezers were maintaining a certain level of temperature to ensure that the ice cream wasn't melting during production. That would be heartbreaking if you opened up a jar of ice cream and it was just a puddle of mess.
Yeah.
So, certainly there are high ends and low ends there. It's not just hotspots. It's also on, for freezing applications as well.
Yeah, definitely. And then so pressure is another one. So any kind of piping system for fluids, be it liquid or gas, differential pressures kind of across the filter to know if you need to change that to make sure your fan or something isn't working too hard. Those are some applications we've seen.
You mentioned, I think we were chatting the other day, you had a customer that was cooling down a panel, right? Because they wanted to prevent overheating and kind of the issues that occur with that. What was that example?
Yeah, so it's in the automotive world, and they had on a press line, they had some panels that were AC cooled. So they needed to make sure that everything in there stayed, at a relatively good temperature.
Yep.
Unfortunately, someone did not close the door. And
they were cooling the entire plant, huh?
Yeah,
wow.
So the compressor could have kept running. And then, if there was any downtime related to that would have been devastating for them. So, I mean, that's a very simple thing, but it works well, and it's a good initial deployment. So, they saw a lot just from some of those low-hanging fruit type applications.
Yeah.
So, if we talk about specifically what our customers have done, we mentioned the panel temperature, that, that's a simple one. We do have had some customers doing current monitoring on cranes. Getting a split core CT, it's pretty easy to install those, and you get, that signal can be brought into, any different system that accepts a 0 to 10, 4 to 20 milliamp. And then that's really more of a condition base. It's not even very predictive on top of that, but it works well.
Yeah. So I have just a quick question. So, it sounds like in a facility environment, these applications are going to be very different or potentially very different. How would somebody look at one solution and try to monitor, like you mentioned, the pressure and the temperature? Yeah. You said 0 to 10, 4 to 20. Is that something that most most IoT solutions have from a customization and scalable?
Yeah, it's a good question. So when you're looking at doing one of these deployments, you want to have, probably partner with someone who has multiple things that they do. So if you just had vibration monitoring and then you had someone who's monitoring your flow or something like that, now you have different systems that you have to tie in. So, trying to find a system that can do more of these things, I think, is an important part in getting a cohesive solution within your facility. So there's more manufacturers who do that. It's just finding the right one.
Yeah.
So.
Well, and I mean, something that I just kind of thought of is, there are still folks that are probably manually walking around and monitoring vibration and temperature with like IR guns or, the vibration technology, but they're doing it on a quarterly basis, biannual, annual basis. And, the pitfall there is you're only getting a snapshot in time.
Mm-hmm. Yeah.
And think about if the equipment isn't running under full load or duress.
Yeah.
Is it even really an accurate picture at that point?
That's a great point, because part of what Grace offers also is like thermal monitoring for electrical equipment. And so with that, you mentioned IR scans. So if you're going to go and want to look at your connection points and make sure that they're not overheating, oftentimes either they do open door, which is very dangerous, or sometimes they'll shut down the machine and get a reading, and that unfortunately is not going to be a very accurate data. Like, of course, it's going to check the box, especially when we're talking insurance related.
Sure.
So it'll do that. But as far as truly knowing the health of your equipment, it is, like you said, a snapshot in time. And sometimes we're not even sure how accurate that snapshot is if it was a low load situation or something like that.
Cool. Thanks.
Yeah. So kind of, how does analytics tie in here? What can we do in order to, take that just data, because data by itself doesn't mean anything. It's just, you can have lots and lots of data and not do anything with it, and that's not going to help anybody. So how do we how do we take that data and turn it into something useful?
Yeah. Well, you touched on vibration, right? So that's something that Grace has been doing now for 5+ years. The idea behind our vibration monitoring is we provide a banded Fourier analysis. So we're looking at subsynchronous band, rotational speed, 1x, 2x, 3x, maybe even a bearing band, to have a deeper dive into how that equipment is performing. So say you're monitoring your equipment over the course of its useful life, right? As that equipment ages, it's going to start to display anomalous behavior. And that anomalous behavior is going to occur on particular bands.
Yeah.
So where that fault is occurring would be indicative of potential faults. Like say there was a fault that occurred on the bearing band.
Yeah.
Could be a loose or deteriorating bearing, or could be just adjusting it and having it fit more tight on the actual piece of equipment itself.
Yeah. Yeah. I mean, that's the thing is there's, the analytics piece is you have to, work with a partner who knows it. And so taking it from just data in this case, we're talking vibration, that's an important thing, is to look at not just the overall levels, but specific frequencies will tell you more about your equipment and let you be able to build on top of the predictive side of when it will fail, how it will fail, when we need to do the work.
Yep.
There's tons of different monitoring solutions out there that maybe have expertise in a very specific thing. And so, they're building their algorithms based on what they know. So there's that side of it. And then there's also like the very general approach where you put a machine learning algorithm on any data stream. So you just gather data, and after a period of time, it says, okay, here's where your data is. It's kind of trending like this. Let's put in some warning and alarm levels based on where that's looking to be. And over time, it can refine that. And then when it sees that, okay, it's increasing, it's crossed one of these thresholds, that's kind of where they can send out an alarm and alert. And then at that time, that's where the user comes in to determine, is this something I need to drop right now to go do, that type of thing. So it might not be super predictive in nature, but it is utilizing some of the machine learning type, things that have really become more and more prevalent within the industry.
And I totally imagine, AI to be a huge part of that. Like you mentioned, in the next coming years, the machine learning, and then also leveraging artificial intelligence to really kind of understand and help deep dive into that data.
Yeah.
And help the folks that are performing that maintenance truly know and understand what's going on.
Yeah, exactly. Because there's, some of our customers who have monitored things that I've never had monitor elsewhere. And so like, I can't tell you where to put that alarm level. Either the customer might already have data where they know, hey, we need to keep it within these ranges and I want to alarm. Great. We have our information we need. Perfect. But if not, usually that's where the general machine learning comes into play.
Yep.
So
let's kind of discuss, let's round this out. I know that ROI was a part of the general discussion that we were going to cover today. So implementing an IoT solution, where can customers start to realize and see an ROI after implementation?
Yeah. So as we've mentioned, just keeping the machine running. When we bought this piece of equipment that was supposed to produce, it's supposed to be up 99% of the time, and it's supposed to produce this much per hour. Well, if that thing goes offline, our initial capital X expenditure that we calculated an ROI on that goes through the window. It's kind of trying to, the ROI is also can be based on another equipment's ROI. So it's kind of, kind of a double layer there, but you get the return on that machine being up and running. So that's the big thing is the machine uptime. I mean, it's kind of, where the rubber meets the road there.
Yeah.
So.
And I mean, just to add, in process industries alone, unplanned downtime has cost facilities upwards of $20 billion. Billion with a B.
Is that every year? I think that is every year. Yeah, so that's that is a lot of potential savings. Basically, is what you can view that as an opportunity, if you will, as some of our teachers may have liked to call that. And kind of going on that theme. So according to recent research, predictive maintenance can save 8 to 12% over preventative maintenance models and strategies. And then over reactive maintenance, it can be up to 40%. So,
wow.
On those equipment that you can monitor, you can really see a good savings. As you install it, you might not, it's not going to be where you instantly get your money back, but over time, when you have an event or two, you can, pay it off and then your money ahead and you continue to monitor.
Yeah. I mean, having those clear trends anyway, just overall trending out how your equipment is performing over the useful life of the actual piece of equipment itself, I mean, just provides deeper insight. Wouldn't you want to know? I mean, rather than just having a single snapshot in time, a more regular cadence, say even like once an hour or once every 3 hours, 4 hours. I mean, really just that peace of mind alone.
No, that is a big thing. And just, being able to monitor it more frequently and knowing that piece of equipment is running well and you can turn your attention to other places. So kind of another piece with that is also reducing the severity of the fault or the defect to equipment. So, a good example is, a customer had, a bearing that it went bad. And so that could have been caught and prevented. Well, they didn't catch it in time, and so that bearing actually got out of the cage, and the motor was basically just spinning on top of the bearing housing.
Oh, wow.
And tore through that. And so basically now, instead of just replacing a bearing, they have to get a new motor, new bearing, housing, and get it all aligned. And so there's just a lot more work.
Kind of compounding issues because you weren't able to identify that sooner rather than later.
Yeah, and that's a common theme of just even like I said, we're not going to put this on there, and it's going to stop any kind of maintenance activity on that equipment. That'd be great. Throw them on everything, and we're
solves
done.
all your problems.
We're
right?
done. But it will potentially reduce the amount of money you have to spend on that equipment if you're able to catch it in a timely fashion, so it's not as severe of a defect.
Yep, sure.
And so we've had quite a few customers who have used it, and a lot of them we've kind of looped back with trying to figure out what are you guys seeing from ROI? How's the system working for you? And generally speaking, we're seeing that they're catching on a system of say 50 assets that are monitored. They have caught say 10% of those. They've caught something on.
Wow.
Within about a 3-year span. So it's not, like I said, it's not overnight. But with those, I think every one of our customers that we interviewed in this, so it was, a subset of our customers that we were able to get in contact with, but they pretty much said that, they've seen their ROI on that. So that's great to hear. And I know a lot of them are looking, like I said, it's generally not a plant-wide thing. So they're looking to do their next kind of deployment with it. So once you get it in there and you are able to provide value, it's much easier to sell internally and move that kind of to where we're looking at more assets and more data and less things that are unmonitored.
Yeah. So we touched on ROI. I think there is another piece that kind of ties in or correlates closely with ROI that may be a little harder to kind of put a value to, but in terms of safety, reducing risk, electrical injuries, folks that are reacting to getting their equipment back up and running are 5 times more likely to have an electrical injury occur. Yeah. So with the implementation of an IoT solution, you're having more insight into how that equipment is performing, and you're reducing that reactionary maintenance.
Yeah, you're having control, and you're able to get a PM that's nice and scheduled. We have a downtime. We can get in there. It's not, hey, we need to get that thing up and running, and so you might show off the wrong disconnect. Yeah. Some lots of things can go wrong when you're just, like you said, if someone's breathing on your neck, you might cut some corners you normally wouldn't. It's unfortunate, and so, like you said, hard to put a number on that. But more and more of the Fortune 500 companies are looking at safety as a mechanism of cost savings.
Absolutely.
One event. Obviously, it's. You want everyone going home in the same condition they came in, but one event also, like from a monetary perspective, can be really impactful.
Yeah. Well, I mean, think about that as well. I mean, it's hard to put a number on that, but say something severe happened and somebody got drastically injured and they're out of work. They're not in the facility, they're not working. Maybe their injuries are so severe that they were hospitalized. Yeah. I mean, really, that it starts to add up. And not only that, like you said, we truly want folks to come into their facility and leave it the same day. We truly believe that we're saving lives, not only with the GraceSense family of products, but all of our brands, GracePort and our permanent electrical safety devices.
Yeah. So definitely, they're kind of all are integral to each other. Some of them are harder to flesh out than others, but that is part of it, and something at Grace we have been doing electrical safety for years, and so that's something that is important to us, is making sure that our customers are safe and they feel safe using our products. So
yep.
Any closing thoughts or anything?
Yeah. So I hate to be salesy. I am in a sales role. I touched on this earlier. I believe Nick Schiltz, who runs our webinars, is going to open up a poll. I touched on something called starter kits. That is a part of our GraceSense Predictive Maintenance family of products. This is a low-cost investment that allows you to physically get your hands on some hardware, software, integration into your SCADA or DCS system, and physically see how the product is going to work for your specific application. These can range from a couple $1,000s upwards of $5,000. We tried to keep it below that $5,000 threshold.
Yeah, absolutely. So also with that, if there's any questions that you guys have, definitely feel free to type them in here, and we'll answer those in the coming minutes. We definitely appreciate everyone taking the time out of their day. We know it's not easy to get away for an hour, half hour. So we do appreciate that. So.
And if you don't feel comfortable asking a question, you can always reach out to myself or Bryce. Yep. We're here to help. Any specific application requirements, Bryce is going to be our go-to man. He's been a part of the IoT family of products for a while now, and has quite a bit of field experience as well.
All right, so while that poll is going, I'll go ahead and read off a few questions that have been submitted throughout the webinar. Okay. I like this first one because we have a graphic behind you, but all we can see are some screens with some maintenance hub images on them. So Bryce is kind of blocking the hardware side of it. So are you a software or hardware company?
Yeah, so we are, true to our core is definitely hardware. In the past about 5 years, we've moved into software side of things as well. But as far as the GraceSense line goes, we're really focused on providing the customer what they want. So that being the hardware, and you can feed that into your system, or you can use our software, get alarms and alerts from that, do trending analytics. So, but we are, I would say, by and large, a hardware company.
Okay. And do we support SAP or Oracle ERP systems for integration?
That is a good question. So we have a variety of mechanisms for getting data out of our system. I have not worked on a SAP integration. We would need to talk offline on the specific requirements, how the data needs to move into it. But we have a variety of ways to do it. It's just finding the best one. For different systems, some of our customers have found it easiest if we hit the control system. And they're, especially in, a lot of the Rockwell world and the compact logics, control logics, get it into tags, and then they can do whatever they want. So that's one approach. And then another approach is direct from our system into another one using either a web-based approach or some type of
API, right? Open
API or some kind of Ethernet-based communication.
Sure.
Okay, I've had a couple of questions about this. And I think it's going to result in me having some homework. So do you have a step-by-step article on how to implement predictive maintenance? We have a lot of articles on predictive maintenance and how to kind of get started, but not necessarily a step-by-step journey. But Bryce, just so I could steal some of your answer here, could you kind of outline what the step-by-step process looks like for new people implementing predictive maintenance?
Yeah, I do agree that Nick has some homework now, and I think that is something that is important. But at a very high level, the first thing is anyone who's worked in the industry or in sales knows the pain point. So where are you experiencing pain as far as this thing is failing a lot, or You just are worried that if it did fail. So, versus identifying equipment, the next would be trying to determine what is the type of way to monitor that. If that's vibration, current, pressure, there's a whole bunch of different things that we haven't touched on, and some really specific technologies too, like motor current signature analysis, things like that. Determining that, finding a partner in that has the hard. We mentioned hardware and software. Has the hardware, software, and like we've mentioned, having some flexibility as far as not getting a very specific system that they only do this, and now then when I try to monitor something else, nope, we don't do that. So that's a big thing. So that's kind of the next step, and then usually trying to get it in a bite-sized chunk of either 1, 2, 3 pieces of equipment, whatever makes sense. And if you have an MRO that you can kind of buy it under, that's kind of key to where you can get it up and testing. And then once you have some results that you can present internally, that's when you can start to look to scale it. So that's what we've seen in a lot of customers. And there's also, depending on the IoT technology you use, if it's cloud-based, we like to use with our customers LTE as a starting system. So it does a cellular connection instead of a Wi-Fi or Ethernet that would oftentimes have to go through an approval process. So that's something that we recommend is a nice way to where you can test it, and then when you go to do a full deployment, now we'll run that up IT to get it set up within our facility.
Oh, so just real quick on that, Nick, I know there's probably more questions. So the LTE side will have basically it'll be in its own system from a deployment perspective. It's not tapping on to an existing network.
Correct. Yep.
Cool.
Yep. It's it doesn't require your infrastructure to connect.
Cool.
Okay, this next one, I'm not sure if Bryce has signed a non-disclosure agreement or if we're ready to announce anything yet, but someone has asked, when will the Maintenance Hub receive the next update? Some customers have asked about a better way to track historical vibration data.
Good question. I have worked with a customer on that recently. I can't disclose too much. I know we are working on that as part of our next release. That'll be slated to be as part of that. I am not at liberty to disclose. I can definitely talk offline and talk with my team, but feel free. I feel like I know who you are to reach out to me directly.
Sorry to put you on the spot there, Bryce. So let's see here. Do you work with other software companies to integrate with your hardware?
Yes, it's really case by case. We don't have any large agreement set up. Besides, we do work really tightly with Rockwell Automation in their really into their control network. So Compact Logix, Control Logix. That's our big one. We're working with them on Fix and some other things like that. Ignitions out there is a kind of agnostic type SCADA deployment that's becoming more popular. So I can't say we have like a necessarily partnership with them, but they just accept data from all different types. So, we're working with them. We're happy to talk with any customer about where do you want the data, and let's see if we can find a good solution in getting it there. If that's working with the other software company directly, or if there's just a native approach that we can utilize, we're happy to address those, because we know, if one customer is asking for it, there's probably another 5-10 behind them that
Sure.
Would like that.
Last question we have is, can the data points be placed in another software platform, specifically ERP systems?
Yeah, so I think that ties directly into the previous question. So it's really about just trying to figure out the most cohesive way to get it there. And it sounds like based on there's 3 or so questions around that, maybe similar ones that were not asked. But so I mean, we've definitely seen that a lot in the industry, but we don't have any partnerships with any large ERPs of a module or something like that. But pretty much every ERP system has a general way that you can connect to it, and so that's how we generally try to get data in there.
All right, let's give Chris one. What cellular service do you use for your gateways?
Yeah, so great question. I know at one point it was Verizon and AT&T, but now I think we transitioned to a hologram LTE, which will just in essence look for the best signal strength and just kind of tap onto that. Bryce, if I missed anything?
No. Yeah, so historically, Verizon, AT&T, for the past year and a half-ish, we've been working with Hologram. So they are basically a general provider that has agreements with all these different cell carriers globally. So it allows us to deploy pretty much anywhere, and as long as you can get a decent cell phone signal. That's a caveat. If you can't use your phone, LTE, unless if we can boost it, there's going to be some trouble with LTE. But that's worked out well for us, and a lot of these Verizon, AT&T, their main goal is cell phone customers. That's so we work on a different band. Every IoT system, for the most part, works on a different band that Hologram is very familiar with, and so they do a lot of work there. So that's why we have partnered with them mainly. And if there was a particular reason to use Verizon or AT&T, we can do it.
All right. That about wraps it up. Thank you, everyone, for attending. So it looks like we had a lot of people join in as a guest, and they weren't able to view the video. There will be an on-demand version of this video sent out, and then someone else had said if you join in the browser, just for future, if you join a Teams meeting in the browser, you should be able to view the video, no problem. Apparently, you can't in the app. That being said, we will send out a follow-up email with a link to the on-demand video and some resources as well. I can't promise I'll have a step-by-step article ready by then, but you're on our list. Thank you all for attending so much. Guys, if you want to say some goodbyes.
Yeah, thank you everyone for your time. We really appreciate it and look forward to working with you all.
Yep, thanks everyone. Appreciate it.